Alright, welcome back to second semester, Calculus BC. And the good news is we don't have that much more left to do. I think about 11 lessons. Here's the schedule. It'll be posted on the homepage on Monday. Today's lesson is pretty nice. If you take a look at the schedule, you'll notice we have 2 lessons this week, 2 lessons the next week, and then 1, 1, 1, 1, 2, and then 1. And then we're done. Most weeks only have 3 assignments. This week has 4. I think every other week only has 3 assignments per week. Try to make this as minimal as possible. That does leave you time on the side to go back and review things that maybe you haven't been thorough on. Most of these lessons stand on their own, so if you're a little bit behind and you feel like you didn't do a good job at the end of the second quarter, we're still in good shape here because each of these can stand on their own. And today's lesson is pretty nice. Everybody could learn today's lesson no matter what you've done up until now. So let's just get to it. It's only 1 page. And the ratio test is going to test whether something converges or diverges. But it may be inconclusive. It may not tell us that. So the ratio test is particularly useful in factorials and exponentials, so that'll help you kind of look for what to use there. So this kind of explains what we're doing. We're going to look at these ratios. That's why it's called the ratio test. And if the ratio is less than 1, it converges. If the ratio is greater than 1, it diverges. And if the ratio equals 1, it's inconclusive, and we'll have to try to figure something else out. Okay, so this process is very nice. So what we're doing is, we're checking a term divided by the term before it. So the easiest way to do that is we want to add 1 to n in both of these cases. So that's going to be 50 to the n plus 1 power over n plus 1 factorial. So even if you didn't really know anything about math, anybody probably could pretty much do that. Add 1 to n. So whatever you have in here in the sigma, add 1 to n. So do that first. So that's pretty simple. Now normally what we would do next is we would be dividing by this term itself. Now that's going to give us a complex fraction, and normally I do a certain thing with that, but here I'm just going to multiply by the reciprocal. So normally we would be dividing by this, so we're going to multiply by the reciprocal there. And so we're literally just writing down the same thing that we had there. So that step is very simple. Add 1 to n. Simple. Multiply by the reciprocal of what you started with. Okay, so that should be pretty simple. Now, we want to take a look at this. So what we're going to do is separate this to 50 to the nth power times 50 to the first power. When you multiply 2 things of the same base, you add the exponents. Okay, so that's what we're going to do with that. Now this, remember in factorial you take whatever's in there and then you subtract 1 from it each time. So 5 factorial is 5 times 4 times 3. And you keep descending. So if we take out the n plus 1 and then we subtract 1 from that, then we would get n. And then n minus 1, n minus 2. This would be our 5. This would be our 4. Then you could continue. But I want to stop there because I can see that I have an n factorial over here. And I can see I have a 50 to the nth there. So these are going to cancel. And these are going to cancel. So now we are down to the limit as n approaches infinity of the absolute value, and we have 50 to the first power, so that's 50 over n plus 1. Alright, and as n approaches infinity, we're going to have 50 over infinity, and that is going to be 0. So we're going to have 0. 0 is less than 1. So according to the ratio test, we're going to say that this converges by the ratio test. Alright, and that's it. I'm going to do that 4 more times and see what happens. Okay, so a little bit more going on here, but the first step is still the same. We're just going to add 1 to n. Okay, so we could put the absolute value on there right now, but I'm going to do that. So this is going to be negative 1 to the n plus 1 power. And then inside here, we're going to have 2 times n plus 1 plus 1 factorial. And all of that's going to be over 2 to the 4 times n plus 1. Okay. So you're just memorizing the steps to start off with. The step is add 1 to n. So that's what we did here, here, and here. There were n's in 3 places. So that is a very straightforward step. Should not be that complicated. And then we're going to multiply by the reciprocal of that. So now when we multiply by the reciprocal of that, we can leave this in the numerator or the denominator. It doesn't really matter. I'm just going to leave it right there. And then actually just take the reciprocal of this. So that's going to be 2 to the 4n power, and down here 2n plus 1 factorial. Okay. Now, because we're taking the absolute value here, we're going to have a negative times well, it depends on what n is, but regardless, this is just affecting the sign, and this is just affecting the sign. And so when we take the absolute value of that, that's going to get knocked out there. Or if we multiply two things the same base, we add the exponents, that'd be 2n plus 1. We could look at that, but it's not going to matter because of the absolute value. So that we want to look there. Now here, if we distribute this, this is going to be 2n plus 2 plus 1. So that's 2n plus 3 inside there. Okay. Now down here, if we look at this, this is going to be 2 to the 4n power times, and if we distribute that, that's going to be 2 to the 4th. Remember, when I just said that over here, when we multiply two things with the same base, we add the exponents. So if we added that, multiply the same base, add the exponents, we have 4n plus 4, and we'd factor out a 4, we would get that. So we're just kind of rewriting these things. The reason that we're doing that is because that's going to allow us to reduce across here. So that's going to go there. And then let's take a look at this. So we have the limit as n approaches infinity, and let's look at this. So this is 2n plus 3, this is 2n plus 1. So if we think about that, that's going to be 2n plus 3. Remember, in a factorial, you subtract 1 each time. So if we subtract 1 from that, we would have 2n plus 2. And then if we subtract 1 from that, we would have 2n plus 1 factorial. I'm going to go ahead and write that out. 2n plus 1 factorial. Okay? And that all canceled. And so down here, we're going to have 2 to the 4th. And then here we would have 2n plus 1 factorial. And that's going to be 1. So that just leaves us with that. So as n approaches infinity here, we're going to have infinity times infinity divided by 16. So infinity squared divided by 16. That's going to be infinity. And infinity is greater than 1. So this diverges by the ratio test. And that's it. Okay, so pretty nice lesson to come back to, honestly. Hopefully you feel that way. So now we're going to try it again. So you could pause that and you could do that yourself. hopefully. Hopefully you can pause it and do one at a time though, or do part of it and then check to make sure you're doing it right. So if we look here, if we add 1 to n, this would be 1 over, that would be n plus 1 to the 5th power, and then the reciprocal here, so that would be n to the 5th over 1. Okay, so now if we take the limit as n approaches infinity of the absolute value, and since these are both to the 5th power, we could have taken the 5th outside the absolute value as well. So as n approaches infinity here, the plus 1 is really going to be insignificant, and so we're going to have 1. So 1 equals 1. So here, the ratio test is inconclusive. All right. Now, what's going to happen is on the test, they may or may not give us any indication of which which test we should use. So here, hopefully, I know it was a couple weeks ago over break. This we can use a different test. This is a p-series. Okay, so little side thought here. So this is a p-series where we have something to the power in the denominator there, and p equals 5. And that is greater than 1. So in the p-series test, what we're looking for is the exponent of the denominator there. And so it converges by the p-series test, is what we would say there. All right, so let's try this again. Hopefully you can pause there and do it. Maybe play as you go one step at a time. So let's see. Okay, now we have k instead of n, but it's the same process. So add 1 to k. There we go. And then multiply by the reciprocal of that. So super nice first lesson, I think, in my opinion. Here. Okay, so now here, this 3 to the k is going to cancel that out. Remember, I could rewrite this as 3 to the k times 3. We have 1 extra 3 there. So that we can factor out. So that's going to be 3. We're taking the limit as k approaches infinity. Here, these are both squared. So we're going to have, again, I could do this k and k plus 1 and squared. Now the fact that it's squared means that we probably don't need that absolute value. We could use parentheses instead, but it doesn't really matter. So here also, this is going to be, as k approaches infinity, this is going to be 1. The plus 1 is insignificant when you have infinity over infinity plus 1. So that's basically 1. 1 times 3 is 3, so that's 3. 3 times 1, if you want to, this is 1. And that's greater than 1. So this diverges by the ratio test. All right. Which takes us to our last example. And all right. So we're going to have k plus 1 factorial squared. So I'm going to write that out. K plus 1 factorial times k plus 1 factorial. Okay. And if we do k plus 1 in here, that's going to be 2k plus 2, because it would, the k plus 1 would be here times 2. So So just go one step at a time. So then we're going to multiply by the reciprocal of that. So that's going to be 2k factorial. And down here I'm going to put k factorial times k factorial. Alright. So if we think about what happens there, we're going to have the limit as k approaches infinity. And here, this is k plus 1 times k factorial. We subtract 1, and then we keep going like that. And so then that, we have k plus 1 times k factorial, and the k factorials cancel out. If I lost you here, make sure you come to office hours, and I will write it out in more details if you need it. I mean, I guess I could do a little bit right here. So we're going to have k plus 1 times k factorial. And so then that k factorial, and then we're going to have the same thing here. And then those k factorials are going to cancel. So that's just going to leave us with k plus 1 times k plus 1 there. And this is 2k plus 2, and if you think about that, that same kind of situation is going to happen. So we're going to have 2k plus 2, and then 2k plus 1, and then 2k. And then we're just going to leave it 2k factorial because that'll cancel with that 2k factorial. So that cancels out. Okay. So if we look at this now, if we multiply that out, that's going to be k squared plus 2k plus 1. And this is going to be 4k squared plus 6k plus 2. Now, if we multiply by 1 over k squared on both of these, then we're going to get 1 plus 2 over k plus 1 over k squared. And down here we're going to get the k squareds cancel out. We're going to get 4 plus 6 over k plus 2 over k squared. So as k approaches infinity, write that down again over here. Those are all going to cancel out, and that just leaves us with 1/4. So 1/4 is less than 1, so that converges by the ratio test. And hey, we are done with the first lesson back. So let's please try to keep up. Don't fall behind. Don't let this go. We're going to be done soon. We have a lot of review. You look at the fourth quarter. Okay, that's the fourth quarter. It's going to take some practice AP tests, and you're just practicing 3 a week. It's the least ever. So the next page in the notes is actually a little way to help you keep track of the different tests. There's nothing to do there, just that's just for you to study. You can take notes on it if you want, and it talks about some of the different situations. And then there's also on the back of that a little flow chart telling you what you should be looking for. Okay, so that's it for that one, and have a good day. It's about that time.